these changes are associated with. In addition, the diagnostic and prognostic implications of different awareness states have yet to be fully elucidated. This featured research session will present work looking at the clinical and biological correlates of different states of awareness, where emphasis has been placed looking at studies employing gold standard methodologies, such as the contribution of individual and/or informant reports of cognitive decline and the discrepancy between the two.
All right, so each presentation will be 12 minutes long, and a full panel discussion and open Q&A will follow after all presentations. With that said, let's begin. Our first speaker is Dr. Gonzalo Sánchez Benavides from Barcelona Beta Brain Research Center, presenting anosognosia trajectory in preclinical Alzheimer's is linked to core pathophysiology, astrocytic reactivity, and structural changes in cognitive control and self-referential brain regions.
Thank you, David. Good afternoon to everyone. Thank you for the opportunity of presenting our results. In fact, as you can see, this work was done in collaboration with David López Martos, who is chairing this session. And I don't have nothing to disclose related to this presentation. And anosognosia, or lack of awareness of a clinical impairment or cognitive impairment, as you know, is a common manifestation in Alzheimer's disease at the dementia stage. But there are also evidences that some degree of anosognosia can be found in MCI patients. The anosognosia is linked to AD pathophysiology and also clinical progression, and in fact, low awareness of cognitive decline in MCI is a bad prognostic marker of progression to dementia. Low awareness is currently not considered in MCI criteria, and in which a subjective cognitive decline is a main core feature. And as we know, SCD, self-reports, are not specific to AD and may be already absent in some MCI patients. Awareness in very early stages of AD is understudied, and we think that understanding it better may help in identifying which individuals are at increased risk of cognitive decline. So the objective of this study was to examine the longitudinal relationship between multimodal biomarkers and metamemory changes, and we understand metamemory as the self-appraisal of own memory performance in cognitively impaired individuals at risk of AD dementia. And by multimodal, I'm saying that we are using several biomarkers coming from CSF, plasma, amyloid PET, tau PET, and MRI. And we performed this study within the Alpha Plus cohort study, which is a cohort composed of middle-aged cognitively unimpaired individuals at the starting of the study. And the main aim of Alpha Plus is to characterize the preclinical course of Alzheimer's disease. We included 350 individuals with all of these measures, and importantly, Alpha Plus individuals are followed up every 3 years, and here we included data from baseline and the first follow-up data. Regarding fluid biomarkers, we studied CSF, beta-40, beta-42, NFL, GFP using NeuroToolkit, p-tau181, total tau, and for plasma biomarkers, we measure NFL, GFP, and also p-tau217 with Eli Lilly assay. We applied ATN classification system in our sample using local cutoffs already published. And regarding neuroimaging methods, we scan individuals twice with 3 Tesla MRI. And also at baseline and follow-up, individuals undergone a full metamol amyloid PET and tau PET only at follow-up. So it's cross-sectional for tau PET. For neuroimaging longitudinal studies, we compute a normalized percentage of change relative to baseline at each voxel and then perform a voxel-wise analysis. So we compute a discrepancy score between objective measures and subjective reports to analyzed to capture this metamemory or awareness feature. For memory assessment, we use the free and acute selective reminding test, memory binding test, and logical memory with a total of 11 variables. And since we are looking at a longitudinal component of memory change, we use a standardized regression-based change index at 3 years, in which an SRB is simply a score that is capturing the discrepancy between the predicted score that the subject should have at follow-up and the actual score that he or she got. So in our case, we made these robust longitudinal norms using the individuals that are biomarker negative, so amyloid negative, tau negative, and neurodegenerative markers negative at both baseline and follow-up, and then calculated like the expected trajectory, the expected SRB from them, like using formulas like this. And we recently published this paper with these longitudinal norms based on amyloid negative individuals. We averaged the zeta scores and obtained a zeta score for objective memory change. For subjective reports, we used the SED questionnaire. We focused on memory domain, which is composed by 11 items. And this questionnaire also is capturing somewhat the longitudinal change because we are asking about changes in memory as compared to 2 years ago. And we also average the zeta score for subjective memory complaints. And we compute finally our measure of metamemory using like simply subtracting both and having the final score in which lower scores mean longitudinal decreased metamemory ability. These are the descriptives. For the full sample, the mean age was about 61 years old. Amyloid-positive individuals were a bit older and have more pathological biomarker levels, obviously, but no differences were seen in objective or subjective, or even in the discrepancy when we compare negative and positive amyloid individuals. When we ran multiple regression models using metamemory as dependent variables and biomarkers as predictors with the covariates that you can see here in the formula, we saw that for the CSF p-tau beta 42 ratio, this biomarker was related to decreased awareness, both at baseline, using CSF baseline levels, but also the longitudinal change of this measure. Regarding these other measures for plasma p-tau217, NFL, and GFAP, we found significant associations also with decreased metamemory ability, but only using baseline scores, but not the longitudinal change of the biomarkers. Regarding PET, these are the results for the baseline amyloid PET. As you can see here, there were a relationship in wide regions, mainly in medial brain regions, and in which the higher the amyloid deposition, the higher the lower the metamemory ability. For longitudinal PET, we saw increments in amyloid deposition in the precuneus, in frontal, and in temporal regions. And for tau PET, which was cross-sectional, as you may remember, we found that there was an association in the medial temporal lobe extending to the insula, only in the right hemisphere. Regarding MRI, this is baseline MRI for the negative contrast, so low gray matter levels at baseline were related to metamemory in these frontal regions, including also the cingulate and others. And we also observed at baseline some positive associations in which some regions display higher gray matter volumes associated with this decrease in metamemory ability. For the longitudinal measures, we found increases, not decreases, in gray matter volumes in frontal, insular, and subcortical regions. But importantly, when we studied the interaction between metamemory decline and AD pathology as measured by CSF p-tau habitat 42 ratio, we found this longitudinal atrophy in bilateral hippocampus, cingulate cortex, and insula, suggesting that the association between metamemory and atrophy is related to AD pathology. So to summarize, we use a metamemory score by subtracting subjective cell ratings of change from robust longitudinal memory change in cognitively unimpaired individuals at risk of AD. I think that this is the main novelty of the study. We are using longitudinal measures as measures of change in both subjective or objective. Our results, in line with previous studies, suggest that the decline in metamemory is linked to AD pathophysiology and structural brain changes, even in pre-MCI stages. So for PET analysis, we observe associations between low awareness and amyloid deposition, both cross-sectionally and longitudinally in medial regions, mainly in frontal, parietal, and cingulate, and these areas have been related to the processing of cell-referential information by previous studies and some meta-analysis using fMRI. For tau PET, we saw this cross-sectional association with medial temporal lobe and the insula, and importantly, the insula and insular atrophy has been related to low ability to recognize own feelings and mood, and specifically also with memory awareness in MCI patients. In MRI, we found these both decrements and increments in roughly the same regions that we found the changes in the amyloid deposition and tau, and probably they are reflecting AD-related atrophy or inflammation processes. And as a take-home message, I would say that low awareness of memory performance really relates to AD pathological changes at very early stages, as in our cohort. And some individuals at higher risk of clinical progression might be overlooked because they do not present or minimize the subtle memory change that they may be experiencing. And we think that using metamemory metrics in combination with AD biomarkers could be useful for identifying such individuals. So I would like to thank my colleagues at the Barcelona Beta Brain Research Center, the funders, and especially Alzheimer's Association for the Travel Fellowship. And thank you for your attention.
Thanks, Gonzalo. Our next speaker is Dr. Manuela Tondelli from University of Modena at Reggio Emilia in Italy, presenting functional connectivity dysregulation across the awareness continuum in Alzheimer's disease, from hypernosognosia to anosognosia.
Okay, thank you. Thank you to the panel for inviting me. And I present today our study about functional connectivity dysregulation. I'm a neurologist and clinician in a university hospital. I have nothing to disclose. We all know that in AD continuum, awareness is not a static phenomenon, but self-awareness level seems to vary dynamically from a normal awareness stage in which individuals experience normal and correct estimation of their cognitive performance through a phase termed hypernosognosia, in which individuals can experience an heightened awareness of normal memory performance. So they experience a sort of subestimation of their cognitive performance. They feel that there's something maybe wrong with their memory or their cognitive abilities, even if they perform totally well in cognitive objective tasks. Finally, on the opposite side, we have the stage of anosognosia, in which we have an impairment of self-estimation. So patients often overestimate their actual performance. The neural mechanism underlying this awareness variation remains poorly understood. Recent research has implicated the dysregulation of major large-scale brain networks in awareness continuum. In particular, the deFOMOD network and the salience network are the two larger networks involved in this mechanism. We know that the deFOMOD network is a resting state fMRI network involved in self-referential, self-processing measure, and is anchored to cortical amygdala structure mainly, including medial prefrontal cortex and posterior cingulate and precuneus. And the salience network is a resting state fMRI network known to be involved in detecting, processing, and integrating internally and externally generated salient information. So our research question was this one: how does functional connectivity within the deFOMOD network and salient network vary across different levels of awareness in a D continuum? And is it possible to identify a neural network signature of awareness that could serve as a potential marker of the preclinical stages of Alzheimer's disease? To answer these questions, we recruited 60 patients, 30 AD and 30 amnestic MCI, and their carers. They performed normal clinical and neuropsychological evaluation to be sure of the diagnosis, and the global cognitive impairment was assessed by mini mental state examination, and awareness was determined using a nosognosia questionnaire dementia. That is a measure of discrepancy between the patient assessment and the caregiver assessment. So the higher the score, the higher the degree of discrepancy, the higher the anosognosia. So a positive score means that the caregivers consider the patient more impaired than the patient himself, considering themselves or herself. Based upon AQD, we classified our patients in 3 groups. We considered the hyper-aware patient if AQD was minus 14. We considered unaware patients if AQD was over 14. And we considered patient accurately aware if AQD was between minus 14 and 14. Our patients did not differ in the groups for sex, age, and years of education. As expected, they differed in AQD scores and also in mini mental state examination, global cognition. We found a significant difference between hyper-aware patients and unaware patients, and also between accurately aware and unaware patients, but we did not find a significant difference between hyper-aware and accurately aware patients. All patients underwent a 3D scanner and to acquire functional data. fMRI preprocessing and analysis were performed using FSL tools, and we applied an independent component analysis using Melodic, and functional data were compared between the 3 groups, considering DMN and salience network functional connectivity. Importantly, we considered age, MMSE score, and gray matter volume as a regressor of no interest in all analysis, in order to be sure that our results were not driven by difference in global stage, global atrophy, for example, or global cognitive stage. So what did we find? We found that hyper-aware patients had greater functional connectivity within posterior cingulate in comparison to unaware and accurately aware subject, and with the mid-cingulate cortex in comparison to accurately aware only. And here you can see the higher activation depicted in blue. On the other side, on the opposite side, the unaware patients had greater salience functional connectivity within anterior cingulate in comparison to hyper-aware, and within anterior cingulate, anterior insula, and basal ganglia in comparison to accurately aware only. And here you can see the hyperactivation in salience network depicted in orange. So our results show that there's a gradient pattern of network recruitment across awareness states. We have a balanced network activity between default mode network and silence network in the accurate normal self-awareness state. And if we look at hyperanosognosia, we see an imbalance between these two networks, and we see an enhanced DMN, default mode network connectivity. On the contrary, in anosognosia, this imbalance sees an increase of silence network connectivity. So in anosognosia, the decreased DMN-related functional connectivity that we know is involved in inner experience and self-reflection is associated to an excessively increased silence network-related functional connectivity that is involved in mechanism of integration of external silent data. We can speculate that if DMN, the default mode network, fails in the continuum of AD, it failed to sustain the updating and the evaluation of new information in relation to personal knowledge, leading to the well-known concept of the petrification of the self, an attentional shift to salient external data occurs, producing hyperconnectivity in silence network nodes, probably maladaptive rather than compensatory. So we are aware that our study has strengths and limitation. First of all, the limitation. We used only one method to measure awareness, the discrepancy score between patient and caregiver. And we all know that in clinical practice, the discrepancy score can be biased by, for example, the burden of the caregiver or the distress or the depression. So we have to account for this difference. And we all know that other measures of awareness can be implemented and can be used, for example, clinical judgment that is based only upon the clinician judgment, or another measure can be the discrepancy score between self-assessment and the objective actual performance on objective task. So we have to be aware that if we use different measures of assessment, we can measure something different and subtle features of awareness phenomenon. Anosognosia and awareness is a complex phenomenon. It's not an all or nothing phenomenon. We can be aware of, for example, our memory problems, but we cannot aware of for example, the functional consequence of our memory problem. So we have patients that are aware of a special problem, but they want to drive the car. So it's very complex to disentangle all these features and to use an objective measure and to be sure to see what we want to see. On the other hand, we are relatively sure that in our study we used age and disease severity expressed as mini-mental score evaluation and gray matter maps as a regressors of no interest. So what we have found is really expression of the awareness status and not the decline or the cognitive impairment status. Finally, let's take home message. We found a network dysregulation that follows a predictable trajectory from hypernosognosia to anosognosia, and we are aware that different awareness states possibly engage distinct neural mechanisms, and probably we can speculate that targeting the DMN connectivity changes could enhance early detection of strategies in preclinical AD, and we are also aware that longitudinal studies are needed tracking awareness changes over time to confirm our result, and in particular it is very important to integrate neuroimaging findings with, for example, other biological biomarkers, as you have already exposed by my previous speaker, for comprehensive assessment protocols. So thank you for your attention. Thank you to all my sparring colleagues, in particular my mentor, Giovanna Zamboni, and my colleagues, Daniela Ballotta and Riccardo Maramotti, who are our hardcore imagers and who support me every day, and they are also here in Toronto to support me. Thank you so much.
Thanks, Manuela. Our next speaker is Dr. Federica Cacciamani, presenting Leveraging Informant Perspectives to Evaluate Cognitive Decline, Key Characteristics of Ideal Informants.
Okay, thank you. Thank you, David. So my name is Federica Cacciamani from ENS École Normale Supérieure in Paris, France. And today I'll talk about how the characteristics of informants, so family members or friends who report on someone's cognition, can influence their report. I have nothing to disclose. So informants are key to detecting early decline, especially when patients lack insight, as we'll hear today. Indeed, many standardized tools have been specifically designed to collect the informant input. And we've heard yesterday a very interesting session about cognitive practice guidelines and about 88, which is an informant-based questionnaire. So we have many standardized tools completed by the informants, and the presence of informants is required in many clinical trials, including major clinical trials, for example, Trailblazer on donanemab, and they are needed for symptom corroboration and follow-up. However, even if the presence of an informant is so important and so used in research and clinical practice, the selection of informants is often arbitrary and based on vague criteria. For example, we look for informants who who know the patient well, for example, or are willing to come to visits with the patient. So these are very vague criteria. And there are few studies on which informant characteristics, such as age or sex, influence report accuracy. And there are even fewer that examine the role of informants over time. And so we can ask, does one type of informant, for example, males or females, become more reliable than others at certain stages of disease? So our objective was to understand whether who the informant is affects how the report changes in the patient's functioning over time. So we had a longitudinal dimension. So we used the NAC data set, which is a very large American data set, and we selected a subsample of 1,382 participants who were diagnosed with dementia during the follow-up. So we had some visits before and after the diagnosis, and most of them actually had Alzheimer's dementia, but it wasn't a selection criteria. And the median follow-up was about 3 years, with a median number of visits of 4. And each one of these participants had one informant, which was the same one across all visits. And the informants were 65.5 years old, and they had on average 8.5-year gap with the patient. And most of them were female spouses. Most cohabited with the patient and had daily contact. And the average education was relatively high. As a measure, we used the Functional Assessment Scale, the FAS, which is a 10-item questionnaire, which is filled out by the informant. So the informant is rating how dependent the participant is in performing activities such as remembering appointments or paying bills. So we had a score between 0 and 30, where 0 is normal and 30 dependent. And then we had, and this is the main, our main predictors, the informant variables. So informant's age, sex and education, the relationship to the patient, the cohabitation status, and the contact frequency, which was both in presence visit and by phone. And then we had patient-level variables, age, sex, and education, and dementia etiology, which was mostly Alzheimer's. And we used generalized additive mixed models. We tried to predict the FAS, so the informant-based score, using a negative binomial distribution because the FAS was skewed. And we predicted FAS using the informant variables separately. So we had one model for example, informant sex, one for informant education, etc. And we studied the interaction between the informant variable and the time. Time was centered at 0 at the moment of the first dementia diagnosis. So we had a time before the diagnosis and after. And to model time more flexibly, we used B-splines. And then we had patient covariates, and all the other informant covariates were used in each model. So for example, when studying the difference between the report of female and male informants, we put all the other information about the informant in the same model to see what's the specific contribution of, for example, sex, and then random intercept. So here you can see on the x-axis the time, which is centered at the moment of diagnosis, which is 0. And so we had negative values for the time before the diagnosis and positive values, it's after the diagnosis. And you can see that the time was cut into 4 periods by the spline model. So we had a period just before the diagnosis of 2 years, and a period more than 2 years before the diagnosis, and then a period of 1 year after the diagnosis and more than 1 year after. So what we can see is that the FAS, as expected, increased over time and reached the peak after a few years after the diagnosis of dementia. But what was really interesting for us is to study how this trajectory differed according to the informant features. And the only informant feature that was significantly associated with in interaction with time with the FAS was the cohabitation status, meaning that cohabiting and non-cohabiting informants reported similar difficulties across all the follow-up, except for the period of 2 years before the dementia diagnosis. And specifically in this period, cohabiting informants reported significantly more difficulties than non-cohabiting informant. And we estimated FAS in this period. It was 5 for cohabiting and 1 for non-cohabiting, knowing that the cutoff for dependency is 9 in this score. So this was the only interaction effect that was significant. We looked at the main effects, and we found that spouses and other informants, so paid caregivers and friends and other relatives and siblings, reported around 30% more difficulties than children, regardless of time. And informants with moderate, so non-daily contact reported 16% fewer. So those who have daily contact reported more difficulties. And there was a small effect of age. A 10-year increase in informant age is associated with about 14% fewer difficulties, but this was small. And we didn't find any effect for a significant effect for education and sex. So recent findings, including this study and prior work, highlight that not all informants contribute equally to dementia assessment, and key informant characteristics consistently influence the accuracy and timing of reported functional decline. So these results, together with other results from researchers, lay the groundwork for empirically driven informant selection criteria in both research and clinical contexts. So we propose a few practical guidelines and recommendations for informant selection. So the first one is prioritize informants with high exposure, meaning they had to have daily contact with the patient or cohabit with the patient. Prefer spouses or close non-child informants where multiple informants are available. Be aware of informant age effects. This wasn't a big effect, but just be aware that older informants tend to report less difficulties. Avoid basing selection, informant selection on their sex and education. And this is important for us researchers, document and adjust for informant variables while using informant-based measures. We don't always do that, we don't often do that, and we should, because you may introduce bias. And an important point is that these are evidence-based guidelines, but they aren't rigid rules, and we always have to consider practical aspects like who's available, who's engaged, and who's more willing to come to visit, for example, which remain essential informant selection. Thank you for your attention. If you have any questions or feedback, I'll be happy to answer later or online. And I thank our funding sources and my co-author, Sophie Tezenas-Dumoncel. And don't miss our poster, which is available online now, where we compare self and informant referred users on this cognitive screening platform, which is DocMemo, and there are links to dementia risk factors. Thank you.
Thank you so much, Federica. So this is the fourth speaker, which we're going to have online. It's Dr. Joseph Eichenbaum from the University of California, San Francisco. The title of his talk is Plasma p-tau and GFAP are associated with subjective cognitive decline and memory concerns in the remote digital brain health registry cohort.
Hi, everybody. I want to thank the conference organizers for putting all this together. Sorry I couldn't be there in person. Here are my disclosures. All right, so Alzheimer's plasma biomarkers offer a promising, non-invasive approach for screening, early detection, tracking clinical progression, and tracking treatment effects. Specifically, plasma amyloid beta 42/40 and p-tau accurately detect brain amyloid levels and clinical stages and predict future decline. GFAP and NFL can be used alone or in combination with amyloid beta and tau to sensitively detect impairment. So given these facts, a crucial challenge for us is improving scalability and accessibility of these. Subjective cognitive decline is recognized as a very early symptomatic stage of Alzheimer's. It's associated with objective measures of cognition and domains relevant to AD, and it's also associated with AD, CSF, and PET biomarkers. And there's substantial evidence for feasibility and validity of collection of these measures in a remote, unsupervised setting. Okay, so less is known, though, about the relationship between plasma biomarkers and subjective measures. Specifically, p-tau 181 and amyloid beta 42/40 have been investigated with mixed results for subjective measures. Both NFL and GFAP were found to have associations with subjective decline, while p-tau 217 and 231 have not been investigated for relationships with subjective cognitive decline. So the goal for this study has been to investigate the relationship between plasma biomarkers and subjective measures in a remote, unsupervised digital setting, the UCSF Brain Health Registry. All right, so what are our methods? So the UCSF Brain Health Registry. So the BHR is an internet-based registry with over 104,000 participants. We administer digital unsupervised cognitive tests, and we also collect longitudinal cognitive and health data using self-report questionnaires. This is where our subjective measures will come from. And we have established substantive evidence for feasibility and validity of this remote collection approach. So we've also developed infrastructure for remotely collecting biomarker data. So we started doing this with the remote saliva collection for genetic analysis, and then in 2019 we started to adapt this infrastructure for remote blood collection. The remote blood collection infrastructure is what we use for this study. All right, so our inclusion criteria from the registry. We included participants age 55 and older with no self-report of dementia, and had completed some cognitive assessments and resided in one of 3 California metro areas. So once we identified those participants in the registry with these criteria, they were then sent an automated email to enroll. And once they indicated interest and consented, they used the BHR platform to schedule appointments at one of 40 local Quest Diagnostic Centers in California. And then these participants underwent a blood draw at that center. Once the blood draw was completed, BHR received the information of completion, and we facilitated payment for the participant. That blood was then sent to the UCSF blood bank and stored there in proportion to the Blenau lab at the University of Gothenburg in Sweden for the plasma biomarker analysis. All right, so let's talk about the variables we included in the analysis. For the BHR variables, we included demographics, age, gender, education. We included 2 subjective measures. The first subjective measure is subjective cognitive decline as defined by the Everyday Cognition Scale score. This is a self-report amongst our self-report questionnaires in the BHR. It assesses perceived changes in daily functioning that map onto 6 cognitive domains. A higher score here is worse, indicating more cognitive decline. We also looked at subjective memory concern. This is a question. Are you concerned that you have a memory problem? Yes or no? We also looked at objective cognitive measures, the CogSafe Brief Battery. This is a playing card-based task. We used 4 subtests. For this analysis, we included the accuracy score on the CBB one-card learning subtest. Higher is better, indicating better accuracy. For the plasma biomarkers, these were once again analyzed by Kai Blenau at his lab at University of Gothenburg. It was analyzed using a Simoa single molecule array assay, and the results gave us the following biomarkers: p-tau 231, p-tau 217, amyloid beta 42/40, neurofilament light, and glial fibrillary acidic protein. All right, in terms of our statistical approach, we used linear regression. For the BHR measures, we use them as the independent variables. The plasma biomarkers were the dependent variables. We created separate models for each BHR measure and each plasma biomarker, and we only included measures that were completed within 181 days of blood collection. And the covariates were age, gender, and education. All right, starting with the registry through to the analysis, let's look at some of the characteristics for a moment. So starting with enrollment from the registry, we invited 7,150 participants from the BHR. Of those, 864 enrolled, 629 then from that group completed the blood draw. The average age was about 68 years old. 90% white population, 3% Latino, 70% female, and about 16 years of education. In terms of the BHR variables themselves, you can see the summary statistics here. And in terms of the plasma biomarkers, here's the mean and standard deviation, and the mins and the maxes for all the unit values relative to the biomarker. Awesome. Okay, so here are some of our results of this analysis. This slide summarizes the results of the linear regression models associating different measures in the brain health registry, which you can see here on the left, and each of the plasma biomarkers across the top. In blue, the subjective measures, self-report ECOG, memory concerns, and in the green color, you can see the objective measure, which I previously mentioned, is the cog state brief battery one-card learning score. Then in each of the cells, you see the estimate and the 95% confidence interval for the results of the univariable linear regression models, where significant results with a p of less than 0.005 are indicated in red. All right, so what did we find? Let's start with the self-report ECOG, where higher scores are worse, indicating a report of more subjective decline in cognition. So what we found was a report of more decline is associated with elevated p-tau and GFAP. For the memory concern question, endorsing a memory concern is associated with elevated p-tau 231 and elevated p-tau 217. We found no other significant associations between the subjective measures and any of the other biomarkers, and we found no significant associations between any of the plasma biomarkers and performance on the cog state one-card learning task. All right, awesome. So these results demonstrate the feasibility of remote Alzheimer's plasma biomarker collection and subjective cognitive decline assessment. We found that higher p-tau 217 and p-tau 231 were associated with a self-report of a memory concern. We also found that higher p-tau 217 and GFAP were associated with greater self-reported decline on the everyday cognition scale. There were no significant associations found between subjective measures, amyloid beta 42 over 40 or NFL, and no significant associations found between any plasma biomarkers and objective measure of memory and learning, such as the one-card learning task with the cog state brief battery. So taken together, these results suggest that plasma, p-tau, and GFAP biomarkers may be elevated in older adults with evidence of subjective cognitive decline, and therefore may be able to help identify those at the earliest Alzheimer's clinical stages. This approach can be used in different settings, trials, research studies, and healthcare to efficiently identify older adults at risk. All right, so it's an exciting finding. It does have some limitations. Let's talk about that for a sec, and then let's talk about where we're going to go. So the limitations, the sample lacks ethnocultural and educational diversity. There were selection biases for those with computer and internet access and literacy. And to note, in our feasibility paper, we found that those who were older with lower education from historically included ethnocultural groups and with subjective memory concerns were all less likely to respond, to enroll, and to complete blood collection. In terms of the future work on this theme, we have ongoing studies now focused on plasma biomarker collection in diverse populations in the BHR. We're also evaluating additional methods to maximize accessibility, such as mobile phlebotomy, at-home blood collection using a finger prick assay, and so on. We're also evaluating the ability of these plasma biomarkers to predict future clinical progression and cognitive decline. All right. Big thanks to all of our participants at the BHR and the entire BHR team, UCSF, our collaborators at the University of Göttingen, and all of our collaborators at Quest. Thank you.
Great, and Joseph is going to join us for the panel in a little bit. But now, last but not least, Dr. David Lopez Martos from Massachusetts General Hospital and the Beta group in Spain is going to present characterizing awareness trajectories in aging and preclinical Alzheimer's disease.
All right. Before I begin, I would like to thank the Alzheimer's Association for supporting this conference, and specifically, well, for supporting this research session. It has been well established that Alzheimer's disease encompasses an extended preclinical stage preceding the onset of mild cognitive impairment and dementia, which is characterized by underlying neuropathological changes in the absence of clinical impairment. Over the past 15 years, preclinical AD has been increasingly recognized as a critical window for early detection and implementation of preventive intervention strategies. This is the current clinical staging on the Alzheimer's disease continuum, where stage 2, transitional decline, falls between the asymptomatic stage 1 and cognitive impairment on stage 3. The available recommendations for identifying transitional decline consider objective cognitive measures, subjective reports of cognitive decline, and behavioral changes. Now, in this presentation, I will focus on subjective reports of cognitive decline, also known as SCD. Specifically, I will present a longitudinal approximation to model the awareness of cognitive function, defined as a discrepancy between participant and informant SCD reports. Previous research on awareness has primarily focused on the stage of dementia. Estimates of prevalence suggest that up to 80% of patients with AD dementia may exhibit anosognosia, which we can define in AD as the complete or partial lack of awareness of cognitive capacity. However, the studies in preclinical AD are still few and heterogeneous, reporting both increased and decreased cognitive awareness in cognitively normal population. The available literature suggests the following model. Self-reported cognitive decline may increase in preclinical AD, but then attenuates, while informant reports of cognitive decline continue to rise over time, giving rise to a discrepancy in distinct directions according to distinct stages of the disease. When individuals complain more than the informants, we refer to hypernosognosia, or increased awareness. In contrast, when informants complain more than the individuals themselves, we refer to anosognosia, or decreased awareness. Now, both increased and decreased awareness may originate from AD-related neuropathological changes and thus correspond to early symptoms in preclinical AD. These may serve as markers for early detection and risk stratification, which may contribute to refining clinical staging in diagnostic frameworks. However, the clinical and pathological significance of changes in awareness at this early stage still remains unclear. Therefore, the objective of the present study was to identify distinct awareness of cognitive function trajectories, from now on ACF trajectories, and evaluate their longitudinal associations with clinical and biomarker outcomes in aging and preclinical AD. The present research was conducted in the A4 and LEARN studies, which enrolled a large cohort of older adults who were cognitively normal at baseline. In this research, we included more than 1,600 participants who had available longitudinal reports of SCD as measured by the Cognitive Function Index, the CFI. On the clinical side, we also included the preclinical Alzheimer's Cognitive Composite, the PAC, the Alzheimer's Disease Cooperative Study Activities of Daily Living Prevention Instrument, the ADL, and the Clinical Dementia Rating Scale, the CDR. On the biomarker side, we included the baseline amyloid PET definition and longitudinal measurements of plasma p-tau. Now, this consisted in a 4.5-year longitudinal period, considering 4 visits or time points, matching the CFI administration. To define ACF trajectories, first of all, we computed a CFI discrepancy subtracting participant and partner CFI scores, such that negative values indicated low awareness, partners complaining more than participants, and positive values in this discrepancy indicated high awareness, participants complaining more than partners. A mixed effect regression model adjusted for demographics was used to predict longitudinal changes on the CFI discrepancy over time, using a random slope and a random intercept, accounting for the effect of time within each participant. A cutoff of one z-score on the longitudinal regression slopes derived from this model was used to define increased, stable, and decreased ACF trajectories. The baseline characteristics of ACF trajectories were evaluated using analysis of variance and chi-square tests, while the longitudinal associations of ACF trajectories with clinical and biomarker outcomes were evaluated using mixed effects and generalized regression models adjusted for demographics. The model used to define ACF trajectories showed that there was a main effect of age, indicating that older individuals had lower awareness, a main effect of sex, indicating that males had lower awareness as compared to females, and a main effect of time, indicating an overall reduction in awareness over this period. Moreover, The time interactions showed that older individuals demonstrated a further decline in awareness over time. Regarding the baseline characteristics, most participants, around 80%, were classified as exhibiting unstable awareness of cognitive function trajectory, 10% as exhibiting increased awareness, and the remaining 10% as exhibiting decreased ACF. The decreased ACF trajectory had greater biomarker abnormalities as measured on core 1 AD biomarkers, namely amyloid PET and plasma p-tau. Specifically, I just want to mention here that almost 90% of participants classified with a decreased ACF trajectory were amyloid positive at baseline, compared to less than 70% in both stable and increased ACF trajectories. Moving on to the longitudinal associations regarding PAC, the decreased ACF trajectory showed a significant cognitive decline compared to the stable ACF, whereas the increased ACF trajectory showed a significant reduced practice effect compared to the stable ACF. Regarding daily functioning, the decreased ACF trajectory showed a steep decline compared to the stable ACF, whereas the increased ACF trajectory showed no significant difference compared to the stable ACF. Regarding the CDR, the decreased ACF trajectory showed a steep decline in global functioning, indicated here by higher scores, compared to the stable ACF, whereas the increased ACF trajectory showed no significant difference compared to the stable ACF. Regarding clinical progression, defined as 2 consecutive or final global CDR score greater than 0. Within the full sample of participants, 27% showed clinical progression over this period. Now, within the stable ACF, 18% show progression, within increased ACF, 36% show progression, and within decreased ACF trajectory, 90% participants showed clinical progression. Indeed, the decreased ACF trajectory demonstrated 28 times higher odds of clinical progression compared to the stable ACF, whereas the increased ACF trajectory showed 2.5 times higher odds of clinical progression compared to the stable ACF. Finally, regarding plasma p-tau, the decreased ACF trajectory showed initially high levels and a longitudinal increase in biomarker concentration over time compared to the stable ACF trajectory, whereas the increased ACF trajectory only showed a longitudinal increase in biomarker concentration over time. In summary, the decreased ACF trajectory showed the most adverse outcomes, including a steep cognitive and functional decline, notably high odds of clinical progression, and a substantial increase in plasma p-tau concentration, whereas the increased ACF trajectory showed weaker associations, consisting in a reduced practice effect in cognition but no functional impact, modestly high odds of clinical progression, and a modest increase in plasma p-tau concentration. These findings demonstrate that distinct ACF trajectories hold separate clinical biological significance. The decreased ACF trajectory emerged as the most relevant in preclinical AD, whereas the increased ACF trajectory was less informative, suggesting that it may represent an earlier stage of the disease, a less severe path in AD, or a broad category, including individuals with symptoms non-specific for AD. This study provides preliminary support for conceptualizing a dynamic change in awareness across the AD continuum, potentially emerging as increased awareness of subtle cognitive decline and gradually progressing to decreased cognitive awareness. This interpretation aligns with previous findings from the A4 study, showing that cognition correlated more strongly with the study partner CFI than with the participant CFI over time, a relationship driven by amyloid burden. Alternatively, increased ACF may also represent a distinct trajectory in which individuals maintain their cognitive awareness until more advanced AD stages. We know that some patients at the mild dementia stage are aware of the deficits and limitations. But increased ACF may also represent a non-specific category, as it may encompass a broad spectrum of individuals, including those undergoing early AD-related changes, as well as those with symptoms non-specific for AD. Previous research has shown that the overestimation of cognitive problems may be characteristic of normal aging, while the underestimation may reflect greater risk for cognitive decline. In conclusion, these findings highlight that distinct ACF trajectories reflect distinct biological changes and distinct clinical consequences, supporting the awareness of cognitive function as a relevant marker for early detection and risk stratification. I would like to thank all participants and everyone who hasn't been involved in the A4 and LEARN studies, and all my colleagues and co-authors. Thank you.
Thank you, David. I think we're going to open it up, right, for... Yes, do we have... Yeah. Before we open it up, everybody can go up and ask questions. But before we start, I also want to highlight this research topic that we've had. This is actually volume number 3. If people are interested in contributing, please go online and stay tuned. This is going to be launched in September this year in Frontiers.
All right. Next, we will move to the Q&A session. I'd like to acknowledge all of our speakers and the valuable contributions they have shared today. At this point, we'd like to open the floor for discussion, so you are invited to ask questions, whether directed at specific presenters about their work or more broadly to the panel, if you would like to spark a general conversation. So please don't hesitate to speak up with a question, a comment, or a thought, or use the online chat application. All right, number 6.
Hi, thanks so much for a very nice session. I have a question, maybe mostly directed at Dr. Cacciamani, but for anybody. And it might be a naive question. I am generally working more on the early end of the spectrum. But in terms of informant ability, I would say, and how reliable an informant is, I can imagine there are quite a few situations where you're not going to be able to get an informant who has these ideal characteristics. So I'm wondering if there are interventions for informants themselves or maybe education programs available to improve informant reporting?
I don't think so. It's a very interesting question. I'm not sure it does exist. I don't think so. Are you aware of something like that? No.
No.
No. It would be very interesting to do that, to create that.
Maybe a new research area.
Yes.
All right, number 6.
Yeah, I think it's my micro. And I have a question for the last one. How are you referring SCD and like the awareness construct, or how is like your awareness construct put onto the SCD thing, because like it's a quite differing thing?
All right, thanks for the question. I would like to clarify. The definition of awareness that we used in our study, first of all, consisted in the discrepancy across the entire questionnaire, across the entire CFI. Now, SCD, you could define SCD based on a cutoff on the entire questionnaire, or you could define SCD, as we have seen in other studies, with a yes or no answer to the question of, do you have a memory problem? So how these two dimensions fit in relationship to one another is a very interesting one. In my study, I didn't address this question specifically. It's true that SCD may relate more with increased awareness than the other way around, but you're right in pointing out that these are not the exact same things, and maybe further research is needed to really demonstrate how these distinct dimensions in awareness relate to each other.
We also have a question online for Federica specifically. Why do you think it is that children of patients tend to report fewer symptoms?
I'm not sure, of course, this is speculation, but I think that basically the biggest effect was about cohabitation and frequency of contact. So maybe children are just less frequently exposed to the parent, but it's also true that we had every other informant feature in the same model. So we corrected for cohabitation and frequency of contact in the model about the relationship. So I'm not sure, because we should have isolating this. I'm not sure, but this is what's in top of my head.
I actually have a follow-up question to that. I was wondering if you also looked at, or if it's possible with this kind of analysis to look at interaction effects to see what the perfect informant is.
Yes,
If
we
it's
wanted to
cohabitant.
do that, but we had to reduce the sample size a lot because we wanted to have only diagnosed people, etc. And we didn't have enough power to run like how many interactions? A lot, because we had 6 information features. So yes, it wasn't possible, but yes, that's what I wanted to do, actually. Yeah,
Great.
All right, looks like we have another question on number 6. Please go ahead.
I thought of another question, this time for Dr. Eichenbaum. So you just looked at the one task on the Cogstate brief battery, but there are quite a few tasks, actually. Have you looked at the other ones, or why did you choose just specifically this task to look at?
We did look at the other ones. Yeah, thanks for the question. We didn't find anything significant. Does that answer your question? Can you hear me?
Oh, the microphone is not working. I think
no.
you said thank you.
Oh, yeah, thank you.
Thank you, Josh.
Oh, yeah, number 4.
Hi, thank you. I think my question follows maybe naturally from the last, but it's a question really I'd like to pose to the whole panel. So I was intrigued by that discrepancy between the Cogstate result and what had been seen in some of the more subjective measures of awareness of cognitive function. And I think that it wasn't clear from the other talks that I was able to see whether there is also that kind of discrepancy between an objective measure of cognitive function and objective measures of awareness of cognitive function. I also am not clear on whether that has been evaluated, but it can be, of course, in looking at the calibration of confidence with which participants answer a particular cognitive task and their accuracy, as well as other ways. So my question to the panel is whether there is indeed this dissociation between objective versus subjective assessments of awareness of cognitive function, and yeah, whether that's something that you've seen in multiple assessments or not.
I think that the measure is important. So if you measure the objective performance and then you measure a sort of a feeling of a knowing of the patient before and after the performance, you can capture a difference or a discrepancy, and it's something different from, for example, a discrepancy score between a patient and a caregiver, and it's also different from a clinical judgment. So it's very important to see what you are measuring, and you can have different answers in your study if you use a biomarker or if you use neuroimaging or a neuropsychological approach based upon the measure you use. So I think, yes, it's interesting, and yes, I think that also the definition of subjective cognitive decline is something complex, and I think that is not equally to hyperanosognosia maybe, but it's something broader. So it's complicated to disentangle these aspects, and it's a problem for our study for anosognosia because there's no a gold standard measure to use. So it's interesting to use different measure and also to evaluate the difference between the measurement, I think.
If I can add something, for example, in the SCD field, it was needed some even decades, no, to really starting to really trying to operationalize better in a more standard way, no, how we are measuring subjective cognitive decline and complaints. And for sure, there are several methods to approach to anosognosia, and I think that we all are and agree in that we have to move forward to try to study all of these different approaches, no? Including objective, subjective, discrepancy, informant versus individual, or maybe a composite of everything to better define the awareness status of a patient.
Yeah, I agree. I think it has to do, it might be best approach with some kind of composite measure. We looked both, in our study, we looked both at a general question and at the everyday cognition scale. And we found, it was interesting, I think, that we found different results depending on that. I think that shows the necessity to have a better definition or maybe a more specified definition of subjective decline. In terms of our study, it could also just be, these are all done online. They're not done, you know, in a setting that might be conducive to the accuracy that we need to tie things to subjective measures. It also could be that memory concern and things like that are all related to maybe episodic issues. So someone is able to recognize that they're having problems, but they're not reliably having problems yet, things like that. That could all come in to kind of interfere with the subjective, objective relationship. So I think one of the things that is really important for us to do is kind of align these definitions, like what objective measures are we using and what subjective measures are we using, make sure that they actually are kind of comprehensively able to touch on enough of the possibility space to capture impairment and awareness.
Thank you.
All right, let's perhaps number one.
Yeah, I just wanted to point out that when you're looking at subjective decline and its relation to cognitive function, you're not looking at an objective assessment of cognitive decline because you only have the current cognitive function. And in fact, we published a paper where we had informants and subjects take the ECOG, and we also had cognitive data currently and prior to that assessment, and found that both the informants and the subjects, the correlation between their subjective ratings of decline and actual decline from prior testing were very weakly correlated. So, you know, I think it's important to look at that. I mean, once people are starting to show symptoms, as some of you have looked at in the A4 study or something, you could look at that after the fact, you know, once the disease progression begins. But when you're just looking at the baseline before before someone has a disorder, you're not looking at the actual decline in cognitive function unless you have earlier cognitive data.
That's a great point.
Yeah, I agree.
And number three?
Hi, I'm Katia Andrade from the Institute of Memory and Alzheimer's Disease in Paris. Wonderful symposium. Congratulations to all of you. Nice talks. I have two questions, one to Manuela Tondelli and the other to Federica Cacciamani. Wonderful work, Manuela Tondelli, wonderful. Please, I would like to know whether you have any insights into the key mechanism underlying the default mode network dysregulation.
So I think that we all know that the default mode network is an early mechanism, an early network involved in Alzheimer's disease. So I think that in the default mode network we have our personal knowledge, so our repository of our personal knowledge, and I think that is higher. Default mode network has higher connection with all the brain. So I think that this connection in its nodes, it's crucial to start, I think, the continuum in DAD or continuum in awareness. I think also that is an important node for this connection with the anterior regions and also with subcortical region, mainly for example, error monitoring or...
Absolutely, error monitoring is very important. This is my point, whether damage to the posterior cingulate cortex, earlier damage to the posterior cingulate cortex would be at the origin of the default network
I think so.
dysregulation.
We found mainly posterior cingulate, precuneus, and mid cingulate, so the posterior regions of the default mode network, and we think that it could be reliable. We didn't find the temporal mesial temporal lobe, for example. It was quite surprising, but we think that it depends on the measure we used, because we used the anosognosia questionnaire dementia that measure global anosognosia, not mnemonic anosognosia. So I think that we didn't catch the temporal nodes of the MN.
Yeah, I think it's not so surprising, because I think that the critical mechanism for the emergence of anosognosia is error monitoring failure due to damage to the posterior cingulate cortex. But this is my hypothesis. Okay. Thank you very much.
Thank you for the question.
Thank you. Federica, I would like to know whether you have considered caregiver burden in your... I think this is the main point. I think that it could, in fact, have an impact on these discrepancies that you have found between informants. In fact, you have shown recently that caregiver burden care distinguish normals from prodromal Alzheimer's patients, and this is probably very important.
Yes, thank you, Katia. No, I didn't. I'm not sure we even have this information, but yes, I'm sure it has an impact. I can assume it has an impact. And
because when you mentioned that the caregivers that live, the spouses, in fact, they probably had higher informant rates because they have a higher burden, I don't know.
Burden. And my main message is that we should collect more information about the informant, but not just demographics, but also like caregiver burden and also maybe, something about their personality, their, kind of mindset, something like
absolutely.
that, more psychological things.
Cultural also. Thank you all.
Thank you, Katia.
I also actually have a follow-up question to Katia's question for you, Manuela. Did you also collect DTI? Because I think it could be really interesting to look at the structural connections.
Yeah. Not in this cohort, but we are still looking to other measure, structural measure, and DTI, and also task-related fMRI with audible task and with task on self and other discrepancy during the MRI. So it's still in progress.
That would be interesting to see.
All right, we have more questions on number 6.
Yes, good afternoon. My name is Claudia. My question is for Dr. Manuela. Dr. Manuela, congratulations for your work. And I was wondering, you said that anosognosia is not all or nothing process. So did you consider to analyze your data according to different domains of AQD, for example, memory, functionality, mood and behavior, and language awareness domains?
Yes, so the EQD didn't allow us to perform such a distinction because there's only two domains, one cognitive and functional and one affective, and they are not balanced because there are a lot of questions in cognitive for cognitive status, but a few questions for affective domain. So I think that the AQD is not the correct measure to explore such distinctions. But I think, and I'm really sure from clinical practice, when I started, I was a mindset with, oh, this patient is aware and this patient is not aware, not like this. And the awareness change from one visit to another, change when we look at the cognitive performance. So we ask, what do you think you will perform this task? And the change also across the cognitive task himself or the functional ability. So a patient can express feelings of something wrong for their memory, for example, but then act not in a congruent activity. So it can there's a dissociation between also a cognitive and the functional. So I think it's very interesting to dissociate, but I think that our measure is not suitable for this analysis. I think the ECOG, that is another measure of discrepancy between patient and caregiver, is more adapted to suitable for this analysis, but we don't have this questionnaire in this cohort. So it's for future research. Sure. Thank you.
Thank you.
Yeah, number 6. Yeah.
Hi, thank you very much for this session. My name is Eugenia Radai. I'm from Baycrest in Toronto. So my question is for Dr. Eichenbaum. In your study, were you able to look at sex differences in the relationship between the ECOG and the p-tau217 sex differences? And then the other question is if you have any data on the test-retest reliability of the subjective cognitive decline measures. Thank you.
Yeah, that's a great question. We haven't looked at the test-retest reliability at this point. It's a next step that I think we should integrate into our paper. And then in terms of, sorry, remind me of your other question.
Sex differences in the relationships between the subjective measures and the biomarkers.
Yeah, we found some sex differences in terms of some of the demographics, but when we put them in the model, we didn't find any differences outside of like some of the expected differences within the biomarkers themselves. So we didn't look at it independently though. That would be a next step as well.
Thank you.
Yeah, thank you. Great question.
I actually have one question for you, Gonzalo. Did you also look at longitudinal changes in imaging data? I know you presented some for the PET, but I was wondering if you also had it for the other MRI measures.
Yes, we do. In fact, the only changes that we found in longitudinal MRI in the change analysis are increments in gray matter volume in some AD relevant areas, but not decrements. I presented some interaction effect with AD pathology and the atrophy pattern then arose, but for the simple approach, just looking for the change, we found some increments in AD relevant area.
Yeah, those were really interesting too. And I think you interpreted them as inflammatory, like early inflammatory reactions, like same as previous studies have shown.
An explanation, but and this could be addressed with, for example, diffusivity, images and this kind of metrics, just to really ensure if there's something related to inflammation. Thank you.
think we have a couple of minutes. I don't see anybody out there. Do you want to? Number three. Yes. All right. We're going to end with a question for the whole panel. From your perspective, where is this field heading? What do you see as the main gaps? And are there any key recommendations you'd like to share with us for advancing research or clinical practice? It's a big question.
Can I start?
Yes.
Gold standard measures. I think it's one of the main issues.
Yeah.
I agree. I think that the measure is the big problem because we use different measures, and so often we cannot compare the same if we use something different. So it's, yeah, I think that's the gap. And so a combination of measure maybe could be the solution.
I completely agree, but more on the clinical side, I would say that the more simple way to account for this is just looking carefully to the discrepancy between informants and patients or participants in studies, because having this discrepancy is the most simple way to have some grasp on awareness.
And I think you're right, especially early on, like we've discussed here today as well, when you can't see any changes in the objective measure, really. Right?
So from my own side, I will add that if the patient presents a significant clinical deficit, may be sufficient with cross-sectional assessment to detect, anosognosia type of impairment. But prior to clinical onset, may be extremely relevant to account for a trajectory or a longitudinal change to really demonstrate what's going on there. Otherwise, there might be a lot of variability that may be confounding.
Joseph, do you want to add something?
I think teasing apart, someone mentioned this earlier, teasing apart the trajectory between cognitive and functional impairment is really important in terms of the subjective measures as well. And I think that we're on the way to doing that. I'm appreciating the questions about demographics, but also in our paper, what I hope to be doing is looking at item level everyday cognition with respect to all these different subjective and objective measures. And I think we might get more insight, and that sort of speaks to teasing apart the cognitive and functional aspects. I think getting, again, it's sort of like going back to what I was saying earlier, getting more of a complete kind of model that allows us to integrate both the subjective and cognitive, objective cognitive measures would be kind of a next step for me.
Yeah, that's a great point, Joseph, actually. I don't think there's anything out there, so we're looking forward to seeing those results from you.
Definitely. Thank you. And thanks for all the questions, everybody.
All right, so we're going to finish the session. We truly appreciate your contributions, your questions, and your presence here today. So thank you.